those fraction to decimal conversions from yesterday and make sure that we understand how to put them into terms of percents. And then I'm going to look at 2 problems on your pink worksheet and then let you work during class time. But when you look at this double number line, we still have fractions on the bottom here. 1/4, 1/2, and 3/4. And when you look over here, we know that 1/4 is the same as the decimal 25 hundredths. And by saying that decimal and using our words in English, 25 hundredths, that means 25 per 100. And so that is your percent, 25 per 100. So instead of having the 1 on the end of the percent bar, since it's a percent, we don't have a 1, we have the 100. And so if we can learn our benchmark fractions on the left, we should be able to write all of our percents just as easily on the right. So Jordan, for example, what do you think a 1/4 is in percent?
25.
It has to be 25, because if you think about counting up, you got to get to 100 by even count. So 25, 50, 75, 100. So 25% is the same as a 1/4, even though the decimal for a 1/4 is 0.25, because the number 1/4 falls between 0 and 1, so it has to be, the number value has to be less than 1 and bigger than 0. But we can still use the fraction to think about how to help us with the percent. But remember, percent means per 100. So because of these titles, we're not saying a 1/4 is equal to 25. We're saying a 1/4 is equal to 25%. So there's a little bit different. Okay? So this next one, the 8th counting one, that one was a little harder. So Maeve, what is the decimal for an 8th?
The decimal for an 8 is 0.125.
Right, it's 0.125. So that's over here. Okay? And we already know that the percent for 2/8 would be the same as the percent for a 4, so that would be 25%. And so the percent for an 8 has to be bigger than 0 and smaller than 25% is halfway, so what's that going to be, Davis?
12.5.
Yeah, it's 12.5. So what's really happening, Aiden? What do you think's really happening to this decimal place here when we change this decimal to a percent?
You're moving it over 2.
Yeah, it moves over 2 for every 0 in the 100. The decimal moves over 2. Okay, so Jason, for 3/8, what's the decimal?
3/8 it's 1.375,000.
Yes, so what would so to think of the way he said that, for the percent, you would only think of these 2 numbers first, so 37, that's right, because the 7's in the hundreds place, so this is 37.5%. And then we know this is 50%. And then Isabel, what about this one here for 5/8? What's the percent for 5/8? Yes, that's part of it, 62. 62.5%. Okay, and Isabel, what's the little trick that's really going on here? It's a 0.5%, and if you're looking at this decimal, how do you get from a decimal to a percent? What's the shortcut? By what? And what happens when you multiply by 100, you guys? What moves the decimal? It looks like the decimal moves over, but really, it's because you're multiplying, the number gets bigger by 2 powers of 10. Okay? So 6/8 is the same as 3/4, which is 75%. And then, let's see, Oliver, what about 7/8?
87.5%.
87.5%. So we're not going to do all of these, but we are going to do the thirds, because the thirds are a little bit different. So let's see, Annette, what's the decimal for a third? That's kind of crowded over here. It's 0.33, it repeats, right? So this problem's a little bit different. So Lily, if the decimal repeats forever, how are you going to write that as a percent? You know this has to be between 0 and 100, right? And if you think about looking at all the other double number lines here, when you say, if you were to draw up a nice straight line, your answer should be bigger than 25, but less than 37.
So this is
Right. Good job. Did you guys hear that?
Yeah, it's three repeated percent.
No. 33, because it has to be between 25 and 37, so it's 33.3 repeating percent.
And so since that.
Okay, wait.
That for the next one for 2/6.
So for 2/3,
It would be the same thing, but for 6, so it would be 66.
right. Exactly, because if you look at the yellow line now, 2/3 is, the percent has to be bigger than 62, well, less than 75. And so over here, if you look at that decimal, it really is 0.6666666 forever. So like Wade's saying, this becomes 66.6 with a repeating bar percent. So I want to take a minute, I'm going to pause this to look at a homework question that I'm going to. So what you see here is your in-class assignment, and I just want to make sure that this makes sense to you. Okay, so the high school drama club produced 7 plays. Can you see that? Is that something? Can you guys see that okay?
Yes.
All right. And last year, in different places around town, some of the plays were more popular than other plays. The club kept track of attendance using the percent bars, and so this page has percent bars for all the different plays. Okay, so for each play, fill in the information to express the attendance as a fraction. So that part's review. And if I did that, let's say, Sophia, how would you mark off the fraction? Because what we have to do is figure out the fraction and the percent and also the number of seats occupied. So just to start a problem like this, Sophia, what would you do? What's that look like? Does that look like a familiar thing we've done before?
Yeah, I would probably scratch.
Yeah, look at that. Here's my scratch paper, and what should I do?
Mark how much the particle square is.
Right, so this is tying in old material to new things. And so you just would repeat this process and be precise. Remember, we always want to attend to precision. And then, how's that going to help me with these questions? What do I know?
It says the fraction occupied would be 1/4.
Right, and there's nowhere to write the fraction occupied on here, but I'm still going to just write it below to keep my thoughts organized, because now instead of fraction and decimal, it's really asking for percent. And that's out of 100, remember, like we just talked about?
And the next one is half.
Yeah, Annette, it's 25, right? Because you're taking your 100 and you're dividing it into 4 parts, or you're looking at that double number line we just made, and you remember that 0.25 as a decimal is 25%. So the percent occupied is 25%.
25.
And the seats occupied
The next one.
would just be broken into 4 parts too, because you look at this denominator,
100.
100 seats.
Because it's 400 divided by
Right.
4.
Because it has to be jumps that count up evenly to 400. So I have to divide that 400 down. It tells me that for this first play, 100 seats were occupied. Give me a thumbs up or thumbs down, guys. All right. On the other side, this is review. Let's think about part-to-whole comparison. Wade, why don't you read for me?
Find the equivalent percent for each of the following. Use any method, but show your work.
Okay, and I'm going to use my favorite method, ratio table. Part to whole, because for percents it works so nicely. Jason, what's the part in this problem, part A? What does it say, part A?
Part A, 3 out of 20 students participate in drama club.
So what's the 3?
The 3 apart,
Uh-huh. And what's the whole?
20.
20. And if I want to get to percent, I need per what? So what's a way to get to 100?
Multiply by 5.
Perfect. Times by 5.
15.
15 up here, that's correct.
15, 100. So
15 per 100.
And 15%.
So 15% participate in the drama club, right? You could just say 15% participate. I think at our school it's more. Okay, that's your classwork for today. Just in case you need a little review, I'll post it.